Day 1 for lesson 7, we're comparing functions today. So use what you know you've learned to identify a function. Take a look at this problem. Today was a snow day. Felicity decided to track the snowfall. There are already 2 inches of snow on the ground from a previous storm. That's very important that there are already 2 inches of snow on the ground. So we start with an initial value or an initial amount of snow of 2 inches. Felicia, measured the snow from today's storm at the end of each hour. She found that exactly 1.5 inches of snow fell each hour. So exactly 1.5 inches of snow fell each hour. So each hour, we're going to see an additional 1.5 inches of snow. If it snowed at this rate for 5 hours, how much snow is on the ground at the end of each hour? So I'll say we're getting an additional 1.5 inches each hour. So we have this table, we need to fill it in. We have time at the top in hours and the amount of snow on the ground in inches at the bottom. So in hour 0, we had 2 inches. And the 2 inches matches up with our initial value. So we kind of figure out that initial value means, if we're talking in time, that's our hour 0. So that's what we start off with. We started off with 2 inches. Then each hour we're going to increase the amount of snow in inches by 1.5 inches. So we'll have 1 hour will be the 1.5 plus the 2, which is 3.5, and we're going to continue to increase by 1.5 each hour. So literally, to get from the amount of snow in inches per hour, I'm just going to add 1.5 each hour. Same thing every time. So A, in the table, 0 represents the time when the storm started. How much snow was on the ground then? Remember, we talked about the initial value being 2 inches. There were 2 inches of snow at that time. How much snow fell in the first hour? We also talked about that each hour there is an additional 1.5 inches that fell. So how much snow was on the ground when Felicia measured it at the end of the first hour? And we say it was 3.5 because that's 2 plus 1.5. And we got that because 2 was the initial amount or the initial value. And the 1.5 was the snow that fell in the first hour. Okay. All right. C, describe how you could use addition to find the amount of snow on the ground at the end of each hour. Then complete the table. So I kind of did this backwards, but it's okay. So what you could do is what I did. I kept adding 1.5 inches to the amount of snow on the ground. At the end of the previous hour. All right, and we'll move on to D. Suppose you multiply each hour in the table by the rate 1.5 inches per hour. What else do you have to do to find the total amount of snow that's on the ground? So if we did that and we multiplied the hours by 1.5, if I did 1 times 1.5, I'm going to get my 1.5, right? If I do 2 times 1.5, I'm going to get 3. Well, if I'm looking at my table, for 1, it's supposed to equal 3.5. And for 2, it's supposed to equal 5. Well, it's really easy to say, well, how do I get from 3 to 5? Well, 3 plus what is going to equal that? And 1.5 plus what is going to equal 3.5? And I find that my answer for both would be I needed to add 2 to both of those once I multiply the number of hours by 1.5. So that's my solution for D, that I'm going to add the 2 inches of snow. That's where my 2 came from, that were already on the ground. Okay. E, fill in the blanks to write an equation for the situation. Let S equal the amount of snow on the ground in inches and H equal the hour. So the amount of snow on the ground is equal to 2 plus 1.5 H. Again, we already explained what both of these were in part B. We said 2 is the initial value. Well, that looks crazy. Sorry. Let me fix that. Initial value or amount of snow. And then 1.5 is the additional snowfall per hour. And that is all for these 5 questions on page 58. So we'll go ahead and move on to the second page. Find out more. You are familiar with proportional relationships that start at 0, 0. For example, 0 hours worked means $0 earned. So if you don't work at all, you don't earn any money. The problem on the previous page does not include 0, 0. The problem states that there are already 2 inches of snow on the ground at 0 hours. This function starts at 0, 2, so the initial value or starting output value is 2. Okay, that's one of our new vocabulary words for this lesson, initial value, which is our starting output value. So please highlight that, underline it something in your book. If you don't have that, just write it on the side. Very important. The initial value is the starting output. Okay, it's very important. Okay, so let's look at the graph of this function. We start at 0, 2 here, of course, because at 0 hours we started at 2 inches of snow already on the ground. Then we increase by 1.5 every hour, so we go over 1 and up 1.5. We increase, when we went over 1, we've increased an hour. When we've gone up 1.5, we've increased in the amount of snowfall on the ground. So the graph also shows the rate of change. The x values and y values change at different rates, but the ratio of these changes is always the same. From point to point, the y values change by 1.5 units and the x values change by 1 unit. So the rate of change is 1.5 over 1 or 1.5. You will discover later on in the lesson that functions can have many different initial values and rate of change. All right, and then the reflect question. Dora opened a savings account and deposited $50. So as soon as she opened the account, she deposited $50. So $50 needs to be her initial value. Starting output, right? So when she gets her paycheck each week, Dora will put $25 into the savings account. So she's going to put $25 into the savings account each paycheck or each week. So she'll have her initial value plus her $25 per week. So describe the initial value and rate of change in this situation. So the initial value, of course, is going to be the amount that Dora deposited. When she opened the account. And then her rate of change is the amount she adds to the account each week, which is her $25, which again we already discussed here. So her rate of change is 25, and we know that because it's $25 that Dora adds to her savings every week. Okay, and that is all for day 1.